Hello, in this video we're going to be covering the Naïve Bayes or Naïve Bayesian classifier. We'll be looking at the inside, how it works internally, and how to use Python, or how to use it in Python using sklearn. Okay, so Naïve Bayes is a classification technique that is based on Bayesian or Bayes theorem, and it's based on probabilities, and you might remember that from second year. Okay, the main characteristic of Bayes theorem is that there's an assumption of independence of the predictors. Okay, which is not always the case, but we need to assume that each of your inputs are independent from each other. Okay, so the classifier will assume that the presence of a particular feature or one of your inputs, your sensor data, for one particular class is unrelated to the presence of any other feature. This model is very easy to build and it's very useful for large data sets. You can get extra information down on this link, which is where I got a lot of information on this PowerPoint. So let's have a look at the formula for Bayes theorem. Okay, and as I was saying earlier, it depends on probabilities. So basically what we have is a formula that will calculate the posterior probability based on the probability of the class, the probability of the predictor, and the probability of the conditional probability of the class and the predictor. Or I should say of the predictor given the class. Okay, remember these conditional probabilities that we saw in second year. So for the classifier, what we are going to have is we're going to calculate the probability for each of the classes given the inputs or the predictors or the features, okay, and then the class that has the highest probability will be the one that we are classifying that input to be as. Okay, these calculations will be calculated internally, and at the end what we need to realize is that all these calculations will be done for each class, for each of the inputs. So when we have a test data set, we will calculate the probability of class 1 for that input. Well, it will be down here. We had several features or input values. And then the class that will have the highest probability will be the one that will be returned by the classifier. Okay, so what we're going to do is we're going to look at a very simple example and do it by hand. Okay, so we're going to get a set of values and we're going to calculate the probabilities and then calculate what the class would be. Okay, so we're going to start creating a frequency table from all our data. We'll calculate all the probabilities. We'll use the equation Bayes theorem to calculate the posterior probability for each of the classes. And as we were saying earlier, the class with the highest probability will be the outcome. Okay, we'll start with a very simple example where we have a set of weather values. Okay, so these are our inputs. We open the window and we check what's the weather like, and then we have recorded over a period of time whether this team, whatever soccer team, played or not, depending on the weather. Okay, so the weather is our input, our features, and then the play class, this yes or no, are the two classes, are our target values. Okay, before we do a proper classification, we can start doing a simple probability problem where we check this sentence: players will play if the weather is sunny. And the question is this correct? So we need to calculate the probability and see if we're getting a high probability for that. So we're going to take our data and convert it into a frequency table. So what we're doing is for overcast, we check all the overcast instances in our table and we check what the target value for those is. And in this case, there's 4 yes values. We check sunny, and for sunny we have 1 no, 1, 2, 3 yes, and 2 no's, this no and the top one. So that's where these values are coming from. So we have 2 no's for sunny and 3 yeses for sunny. We do the same for rainy, and we add them all up, all the no's on all the yes values. Okay, now from here, from this frequency table that comes from our original set of training data, we're going to calculate some probabilities or likelihoods. Okay, so what we are calculating is calculating the likelihoods across. So we'll have 4 overcast out of 14 total predictions or inputs, sorry, they're not predictions. Okay, so there's 14 games basically that we've recorded what the weather was like and what happened, if they played or not. So 4 out of 14 were on days that it was overcast. 3 plus 2 is 5 out of the 14 games it was rainy. 5 out of 14 games it was rainy as well. Then looking down here, we have there's 5 days where they didn't play out of 14. That's the probability of not playing. And then there was 9 days where they did play out of 14. Okay, so we have here our likelihoods 0.36, 0.64 for not playing or playing. Okay, now we get into the formula itself. Okay, so in this case we're going to use the Naïve Bayesian equation or formula to calculate the posterior probability for each of the classes. We start with yes, they're playing and it's sunny. The formula says that we need to calculate the probability of being sunny if they are playing. We multiply that by the probability of the team playing, and we divide all of that by the probability of getting a sunny day. Okay, so we work out these values. Okay, and these values are coming again from the previous table. So let's have a look at how we get these values. Okay, so the first value here, the probability that it was sunny on a day that they were playing. So we need to check how many times we go back up here. How many times of the ones where they did play, the yes, that was 9 days they were playing. How many of those it was sunny? So it's 3 divided by 9. We check the next one, the probability of getting a sunny day. We go back and we have 5 days it was sunny out of the 14 that we have records for. Check here the probability that they did play. We go back up and they played all of these days, so 9 days out of the 14 that we have records for, they did play. So that's your 0.64. And then the probability that they play on a sunny day is using the formula. Put in your values into the formula here, down there, and that one over there. So it's 60% probability. If we tried, so this would answer the problem question that we had earlier, where we said players will play if the weather is sunny. So the answer is yes, because we have 60% probability for that. If we wanted to classify, we have the input being a sunny day, and we want to classify whether the team will play or will not play. So we do the calculation for yes, we have it here, and we get our 60%. And then we could do the calculation for no. Okay, so the class is no. The inputs for the test data is, in this case, just one input, it's sunny. And we do repeat the calculations looking back into our formula. You can check these values and see if you see where they're coming from. And the final value is 0.4. So if we were classifying to get a yes or no answer, whether the team will play or not, we will check the probability of class yes, and we get 0.6, the probability of class no, and we get 0.4. So the answer of the classifier would be yes. Okay, and I want you to try the same for overcast and rainy weather. So if we look out the window and it's overcast, can we say if the team is going to play yes or no? And the same thing, we look out and it's rainy, can we tell if the team will play or not? And you have the answers there. I'm going to skip through them very quickly here, and you can go and check yourselves after you've done the calculations. Okay, so what are the pros and cons of this classifier? So it's a very easy and fast way of predicting the class of a test data set. It also works well for different multi-class predictions, so not only yes or no, but like when you have different classes, several more than 2 classes at the end. If your inputs are independent, remember we are saying that we're assuming there's independence between our input values, then the Naïve Bayes classifier performs very well compared to some other models, and you need less training data. Okay, so that's that gives you a very good classifier if the inputs are independent. It's also a very good classifier when we have categorical values. So they're not numbers, they are like sunny or rainy, compared to having 3.5 or whatever, a numerical value. If the values you have are numerical, then we are assuming a Gaussian distribution, like a normal curve, like we studied in semester 1. Okay, and what are the cons for the Naïve Bayes classifier? Okay, if we have a category in the test dataset which did not appear on the training dataset, then you will just get 0 probability and it will not work. Okay, so that is a big problem. Another limitation is, again, we've discussed it already, the independence of the predictors of the inputs. In real life, it's really impossible to assume that they are independent, so that affects the performance at the end of the classifier. Okay, so that's the basic workings of the classifier. How do we implement it in Python? Okay, so we're gonna use our sklearn or scikit-learn library, and there's 3 types of classifier or model that you can create in the library. You can use your Gaussian elimination to use for classification, and it will assume a normal curve distribution of your values. You can choose a multinomial, which is mainly used for discrete counts, meaning that your values cannot take any number of values. They are restricted to particular values. And then we can have a Bernoulli distribution, and this one, or type of model, this model is used when your values, your inputs, are binary, either only 1 or 0. So that's a very particular case, and it's more accurate to use this type of model than to use any of the other ones. It would give you better results. Okay, so how do we implement these in Excel? Oh, sorry, in Python. Okay, so we have an example with a notebook and a video, and then you will be implementing this Naïve Bayesian classifier using data from wearable devices. So we have some individuals performing some weightlifting activities, and there's 4 classes. One of them is when they perform the exercise properly, and then the other 3 are 3 typical mistakes that can happen when you're executing these exercises. So then, given a new data set of the sensors, the accelerometers of the sensors that these individuals have in different parts of their body, then you're going to have to decide, or your classifier will give you an output that will tell you if the exercise is performed correctly, or if it's incorrectly, which of the 3 typical mistakes is happening. Okay, and you will need to submit this exercise. Okay, bye.